13,000 feet beneath the Pacific Ocean, something impossible is happening. Rocks are producing oxygen in complete darkness, something that every biology textbook says can't exist. But here's what makes this discovery truly extraordinary. These same mysterious rocks contain the exact metals needed to power electric vehicles. We're talking about enough material to build batteries for over 1 million cars, just sitting on the ocean floor waiting to be discovered. Now, before you dismiss this as another far-fetched ocean theory, let me show you why major corporations are investing hundreds of millions of dollars to understand these rocks, and why scientists are calling this one of the most significant discoveries of our time. You see, most people assume that oxygen production requires photosynthesis, plants using sunlight to split water molecules and release oxygen into our atmosphere. That's been the fundamental rule of biology for as long as we've studied life on Earth. But what if I told you that nature has been quietly breaking this rule for millions of years in the deepest, darkest parts of our oceans?
These mysterious objects are called polymetallic nodules, and they're scattered across an area of the Pacific Ocean floor, roughly the size of the continental United States. But unlike anything else we've found in nature, each nodule is essentially a perfect battery, containing nickel, cobalt, manganese, and copper in nearly ideal proportions for electric vehicle batteries. Now here's where this story gets truly ancient and mysterious. These nodules don't form quickly. They grow through one of the slowest processes known to science, accumulating layers of metal over millions of years. Imagine a single shark tooth falling to the ocean floor during the time of the dinosaurs. Dissolved metals in the seawater slowly precipitate around this tiny nucleus, building layer upon microscopic layer, until millions of years later, you have a potato-sized rock containing a fortune in battery metals. But the real mystery wasn't discovered until 2024, when scientists made an observation that changed everything we thought we knew about these nodules. They were producing oxygen in complete darkness, without any photosynthesis whatsoever. The scientists discovered that the nodules themselves were generating electrical currents, up to nearly 1 volt, strong enough to split seawater through a process called electrolysis. They were essentially acting as natural batteries, powered by the metals within them, creating what researchers are now calling dark oxygen. Now, let me ask you something. What are the odds that nature would create rocks that perfectly combine the metals we need for modern batteries with the ability to produce oxygen? It's almost as if these nodules were designed for this exact moment in human history. The location where most of these nodules are found is called the Clarion-Clipperton Zone, a vast underwater region stretching over 3,000 miles across the Pacific Ocean between Mexico and Hawaii. This area alone contains an estimated 21 billion tons of nodules. To put that in perspective, that's enough nickel to build batteries for every electric vehicle that could ever be manufactured, enough cobalt to last us centuries, and enough manganese to power industrial applications for generations. But here's what makes this discovery even more intriguing from a historical perspective. Humans have known about these nodules since the 1870s. The HMS Challenger expedition first dredged them up from the deep ocean floor over 150 years ago. Scientists have been studying them, testing them, and trying to understand them for decades. Yet only now are we beginning to grasp their true significance. Here's where the mystery deepens even further. The oxygen production capability of these nodules suggests they've been supporting deep-sea ecosystems for millions of years. We're not just looking at a collection of metal-rich rocks, we're looking at what might be one of Earth's oldest and most stable oxygen-producing systems. Some scientists are now theorizing that similar electrochemical processes might have been crucial for the development of early life on Earth. Before photosynthesis evolved, before plants began producing oxygen, could natural electrical processes in rocks have provided the oxygen that early life forms needed to survive? But this discovery also presents us with a profound dilemma, and this is where the mystery takes on an almost moral dimension. Major corporations are now positioning themselves to begin commercial mining of these nodules. 19 exploration licenses have already been issued by the International Seabed Authority to companies including subsidiaries of Lockheed Martin and major mining corporations from around the world. But here's the mystery that's keeping marine biologists awake at night. If these nodules have been producing oxygen and supporting deep-sea life for millions of years, what happens when we remove them? The deep ocean is one of the least understood environments on our planet. We've explored less than 5% of our oceans, and we're constantly discovering new species and ecosystems that challenge our understanding of how life works. Some of the creatures living near these nodules might have lifespans measured in centuries or even millennia, yet the demand for the metals in these nodules is becoming desperate. Electric vehicle production is projected to increase by 500% over the next 2 decades. The batteries for energy storage systems needed for renewable energy infrastructure require enormous quantities of exactly the metals these nodules contain. So we're faced with an ancient mystery that's become a modern dilemma. Do we harvest these mysterious rocks to power our clean energy future, potentially destroying ecosystems we barely understand? Or do we leave them untouched and continue relying on increasingly destructive land-based mining? But here's where this story takes another fascinating turn, and where the mystery might actually hold its own solution. Scientists are beginning to study whether these nodules could be farmed rather than simply harvested. Think about it, underwater facilities that actively produce battery materials while simultaneously improving ocean health by generating oxygen. It sounds like science fiction, but the discovery that these rocks can generate electricity and split seawater suggests that nature has already solved engineering problems we're only beginning to understand. The reality is that we're standing at the threshold of a new era in both energy production and our understanding of life itself. Within the next few years, test mining operations will provide us with real data about the environmental impacts of nodule harvesting. We'll also gain much deeper insights into how these natural systems work and how we might work with them rather than simply exploiting them. These nodules have been waiting on the ocean floor for millions of years, quietly producing oxygen, concentrating metals, and supporting ecosystems in ways we never imagined possible. They represent a convergence of ancient processes and modern needs that seems almost too perfect to be coincidental. What other secrets are hidden in the depths of our oceans? What other natural systems are operating according to principles we haven't discovered yet? And what other solutions to our modern challenges might nature have been preparing for millions of years? The polymetallic nodules of the Pacific Ocean are more than just a source of battery metals. They're a reminder that our planet is far more mysterious and sophisticated than we often realize. They challenge our assumptions about how life works, how energy systems function, and how we might build a sustainable future. As we stand on the brink of potentially harvesting these ancient treasures, we're forced to confront fundamental questions about our relationship with the natural world. Are we wise enough to unlock the secrets of these nodules without destroying the systems that created them? Whether we're wise enough to honor that preparation and learn from it, that remains the greatest mystery of all. What do you think? Should we harvest these ancient oxygen-producing rocks to power our electric future, or do we need to find ways to learn from them without destroying them? Let me know your thoughts in the comments below. If mysteries like this fascinate you, discoveries that challenge what we thought we knew about our planet, then you'll want to subscribe and hit that notification bell. There are countless secrets still hidden beneath our oceans, and we're just beginning to understand how they might shape our future.